Hi, it's Marco from Donut Lab. You are watching our battery proof series called I Donut Believe. In this series, we demonstrate the capabilities of Donut battery, which is the world's first solid-state battery used in production vehicles. Now, in real-world applications, customers want two things: simple integration and great battery performance. In reality, that combination has been kind of out of reach. Solid-state batteries come with the well-known challenge: swelling and compression requirements. In many cases, 15 to 20% expansion during operation, making system design complex and limiting real-world adoption. But what if you could eliminate that constraint altogether? When you solve swelling, you unlock longer system lifetime and dramatically simpler integration. So in this episode, we show how the donut battery behaves differently. Unlike typical solid-state cells, it operates without significant breathing, enabling efficient and easily integrated battery pack designs. So let's go and take a look at the test.
Thanks, Marco. The full report made by VTT is again available for download at idonotbelieve.com. So let's dive in. As we mentioned in the fast charge performance test, all batteries typically swell and shrink during charge and discharge cycles, regardless of the charging method or C rate used. In conventional batteries, this is typically just a few percent, but in solid-state batteries, the expansion can be as high as 20%. This is a real challenge at the pack level because battery pack engineers have to build complicated clamping systems to control a steady amount of pressure on the cell, while also containing that expansion and shrinking during every cycle. The result is that the performance gains you get at the cell level are basically lost at the pack level due to added weight and complexity. Today we are looking at how the donut battery cell handles this breathing across different charge and discharge cycles. This test setup was designed to expose the cell's maximum raw swelling behavior. The cell is placed between two aluminum plates and loaded into VTT's comper pouch device, which is set to apply the absolute minimum pressure possible while still holding the assembly in place. The whole test runs at ambient room temperature while both cell thickness and applied force are recorded continuously throughout cycling. We also chose the cell on purpose. It isn't a fresh, unused cell. It's already been through significant prior usage, which has reduced its 1C capacity by roughly 13% compared to a brand new cell. So what we're measuring here is the swelling behavior of a cell that's already been pushed hard in a rig designed to give us the most extreme reading possible. So this is as close to a worst case scenario as we can get. The test then runs the cell through a range of C rates to evaluate how the breathing behaves in different speeds. Every charge and discharge cycle in the test is using the full depth of charge, meaning 2.7 to 4.15 volts. It starts with 4 cycles at 0.5 C, then 4 cycles at 1 C, then 20 consecutive cycles at 2 C, and finishes with another 4 cycles at 0.5 C. Looking at the results, it's clear that the breathing during each cycle is minimal, around 4.4%. Now that is roughly just 1/5 of the up to 20% swelling that is typical for other solid-state batteries. And we're seeing it on a cell that's seen a long and harsh lifetime already, measured under worst-case conditions. And critically, the 4.4% is the same regardless of whether the cell is being cycled at 0.5 C, 1 C, or 2 C. Across the entire test, the cell also expanded permanently by around 0.8%. And that small permanent expansion is normal for a cell that's been in use for a long time and is now cycling in very different conditions. This is the kind of gradual change that standard pack design routinely accommodates with a small amount of natural compression. What all of this means at the pack level is significant. There are no extra clamping mechanisms or specialized compression systems needed to manage cell expansion and shrinking. This means the donut battery can be integrated into pack designs the same way as conventional cells with no special engineering required, and the cell level performance actually carries through to the pack.
Thank you, Ville. That's all for today. So thank you for watching and see you guys next time.